Good morning everyone. The topic for my presentation is electrodeposition of nickel coating on 304 steel in laboratory produced saline water and feasibility of developing chloride ion battery in the same solution with nickel plating. Coming to the contents of the presentation, and this is the introduction. Can corrosion be used to meet the energy demands? So as we know that there is an increased demand for the energy, which has led to the development of existing battery and new material systems so that electrochemical energy can be synthesized at an economically cheaper rate, and henceforth its demand in the fuel efficient aircraft and future cars and other systems. So this form of energy is purely electrochemical and it's dependent on electrodes, electrolytes and reversible reactions. Now, with the innovation of these nanostructured materials, we get a more energy efficient battery system with a lower cost and which proves to be competitive in the market as compared to primary and rechargeable batteries. Also, nanomaterials, they have huge potential in applications of energy conversion and storage devices because these materials provide additional electrode surface area with short path lengths for electronic and ionic transport and hence provide the possibility of higher reaction rates. Also, we have a finer control of the grain size and surface morphology by control of current, potential and chemistry of the electrolyte. Now, metal chloride systems show a large Gibbs free energy change yielding a high EMF value during the chloride ion transfer when they are used as electrolyte in batteries with a highly electrocatalytic nanodeposited material serving as the anode. And solid inorganic compounds like PbCl2, SnCl2, they show fast chloride transfer at very high temperatures. So efforts to produce alternative energy at an economically viable cost can be used to reduce the increasing demand for the energy. And the main aim of this project is to synthesize electrodeposited nickel as battery electrode by optimally controlling the parameters and rendering the process cost effective by adding nickel in small quantities and in the form of nickel sulfate solution for electroplating nickel on mild steel, which is used as the anode material to give a huge current in the chloride ion batteries. So the advantages, as we have discussed, are low cost equipment, high deposition rate, non-toxicity being some of. So we coming to the principle of electrodeposition. Metals or oxides can be deposited at cathode or anode from cations or anions in the electrolyte by passing a desired amount of current at a fixed potential. So if we consider the cathode reaction is given here, also the anode reaction, if we consider the overall reaction as Ni2 plus H2O giving nickel in solid form plus oxygen plus hydrogen plus iron. So the reversible standard cell potential is minus 1.48 volts, and if we calculate the non-reversible standard cell potential, that comes up to be minus 1.2145 volts. So basically for electrodeposition of nickel to occur, the applied potential should be more than minus 1.2145 volts. Now, experimental procedure. The starting material used was mild steel rod of diameter 1 centimeter. Before this, we need to take care of the surface preparation. Otherwise, there may be nucleating sites which may lead to a non-uniform coating, and this arises mainly from the scratches on the surface. So, pre-treatment is done by cleaning the samples in alkali solution. And next, a solution of nickel sulfate is prepared by having 1 molar nickel 2 plus concentration to which the clean steel piece is dipped into it, serving as a cathode, and saturated calomel electrode is the reference electrode and graphite is the anode. Slowly the potential is increased till 2 to 3 milliamperes of current is passed, and at steady state the sample is kept for around 5 minutes and it is observed whether the steel is coated. Next, tests like cyclic voltammetry, chronoamperometry, and potentiodynamic polarization tests are performed to check the performance of the coated material as the battery. So coming to the results for cyclic voltammetry, we see that the curves they show a peak current density at a fixed potential where we get a good amount of energy, and high currents obtained in the curves having different morphology of nickel coatings obtained by changing the electrodeposition current, we can see that as the current applied increases, the maximum current obtained also increases to around 1.125 amperes per centimeter square. So we can say that we can obtain a good amount of energy when it is used as anode battery system. And then chronoamperometry results, the operating parameters were changed here also at prefix potentials, and at certain fixed potential values these curves were registered. So from this curve we can see that with an increase in applied current or for higher potential values, the curves shift upward, giving a higher steady current for a long time, establishing it as a future battery electrode material. Next, we come to the potentiodynamic polarization tests, which were performed for different morphologies of coatings by changing the electrodeposition current as done earlier. And the electrolyte used was 3.5% Cl minus solution, and we used these electrodes as given in the table, such as reference electrode, counter electrode, and working electrode. And from the plot, we can see that the curves keep shifting upwards towards the right with increase in electrodeposition current, which means that we are generating more and more current, and the exchange current density is also very high. Also, the reversible cell potential increases with increasing electrodeposition current, which means we are getting more and more energy. So effectively, less number of cells are required for development. These are the optical microscopy results in unetched condition. These micrographs reveal a globular morphology which indicates that higher surface area of the material is synthesized for the given same volume, leading to better electrocatalytic properties. And the XRD results here show that the highest peak is obtained at nearly 45 degrees, showing the presence of nickel, with a few other peaks of pyrrhotite, which may be present also as an impurity on the surface of the deposit. So the conclusions, the electrochemical characterization tests like cyclic voltammetry tests, they show that the high current can be obtained in the chloride battery system, having electrodeposited nickel as the high energetic anode material. And all these tests, they reveal that like potentiodynamic polarization tests reveal that we are generating more and more current and subsequently energy with increase in the electrodeposition current. Even the XRD results, they confirm the presence of metallic nickel on the surface of the deposits, and the optical microscopy images, they showed the globular morphology, which is indicative of high electrocatalytic property of nickel. So all the results show that electroplated nickel, it can be used as a high energetic anode material in futuristic chloride ion batteries, and can be used as alternative sources of energy over the conventional ones. Thank you.